Welcome to BS&BEER Canada. I'm Aaron Jones. I'm a carpenter and builder in Grand Manan, Canada, or Grand Manan, New Brunswick, Canada. Uh, I'm a high performance enthusiast, a little bit of a blower door nut, and tonight I am drinking half cut from a local brewery. Anyways, we won't get into that, but we'll go over to you, Connor, and you can tell us a little bit what's going on with you.
Sounds killer. Hey everybody, I'm Connor Malloy. I'm a builder, educator, and designer in Toronto. I teach full-time at George Brown College. We have an excellent building and renovation program. I as well, like Aaron, am a blower door nut and like everything about airtightness testing, and like to teach students and young carpenters about, the power of building well-constructed envelopes. I'm drinking something very patriotic. This is a Great Lakes Brewery Canuck, and it's great to be here. Over to you, Justin.
Hey everyone, Justin Ott. I am a custom home builder and renovation company in Saskatchewan, and we focus on high performance builds, passive house, net zero, deep retrofits. And yeah, we're just really trying to focus on bringing high performance back to Saskatchewan where it kind of all started. Oh, sorry. And tonight I'm having a Red Bull because it's been a long day.
Well, it's my absolute pleasure this evening to introduce Kenny Steens, I believe it is. And if I mispronounce that, Kenny, I apologize. I meant to confirm that beforehand, but it didn't happen. Anyways, Kenny is with Performance Haus, and he is going to give us a little rundown on mechanicals and probably a few other little surprises along the way. Um, if you don't already know Kenny or Performance Haus, you can find Kenny on IG at Performance Haus and BS&BEER Edmonton, I believe. Anyways, Kenny, what are you drinking and what are we talking about?
You bet. Thanks. I appreciate being here. I have two drinks. One, obviously, Canadian classic, Snur. And then one more, a little bit better for the palate. This one's 33 Acres of Darkness out in BC. A nice little stout. So those are my selections of choice. And yeah, I'm with Performance Haus. Operations manager is my role. So focusing on the business operations, inventory and management. And it's been a couple months here. Previously, I was at doing some mechanical design. I had a mechanical contracting company, and that shifted into some of the design. So my experience is more so the mechanicals more than the building envelope. But like all of you guys, definitely a blower door nut. So.
Well, whenever you're ready, Kenny, just let's dive in. And there'll be plenty of time for questions at the end. And we'll probably just open the floor up so that anybody can come in and we can have just a really good discussion and, you know, talk about everything you've got to offer here.
Sounds great. So here, I'll pull up my little slides. All right. So mechanical systems and high performance homes, thinking about it and what value to bring to people. If you're a homeowner, if you're a home builder, what are some things that you guys can consider and know more on the mechanical side of things, and also struggles that we've all experienced with mechanicals in building in general, and how unique it can be in high performance homes. But designing for performance, it does starting with the understanding of the whole picture, the air assemblies, the air tightness, climate, windows, and even the unique needs of occupants. We've had a few projects where some of the occupant needs, whether there's some specific handicap services, but they want to do it in high performance, and having those complications that can lead to things. But can get into a little bit more of that. So again, my name is Kenny Stennes, to pronounce correctly. I had a mechanical contracting company for about 10 years in Edmonton here. We specialized in the luxury custom homes, and that transitioned the last couple of years into more the mechanical design side. We found that when we were asked to quote for a project, it became more of an educational session for the homeowner or the builder and the whole building as a systems concept. And through research in Passive House and just nerding out through the rabbit hole myself, started understanding how important the building envelope was. And that changed everything from how we were consulting and quoting on projects. So then that led me to start a mechanical design firm. I still have that going, Inform Designs, and we'll spec equipment specifically for high performance homes, passive houses, and the unique needs of those projects. So there's a few key principles that I wanted to go through of just mechanical systems design. Number one, which I think we can all agree with, is start with the building, start with the envelope. And that's something that's just not as thought through with a lot of mechanical design and the concept of what airtightness is doing in the building and how that affects your heating and cooling loads and the indoor air quality. I like this quote, that control your building envelope, control your indoor environment. And one tip for some people who are familiar with RightSoft, which is a common residential mechanical design software, is that you can go into settings and change things so you get a specific ACH 50 infiltration number, and that will impact heat loads for each room and your whole home.
Hate to interrupt, Kenny, but if somebody listening or watching wanted to get their hands on the right soft, where would they go to find that? Is it available, online, or is there a specific place you have to go purchase that from?
Yeah, it's purchased online at rightsoft.com. Anybody can purchase it, and it's a bit of a archaic program in a way of how it's the user interface is, which they just did come up with a new update. But what it does do for the numbers, if you're doing a manual J or a F280 calculation to get those heating and cooling numbers, it's a great user-friendly tool in that way. And you can adjust assemblies and window U values and create your theoretically a model on paper, and then we'll often refer to that on some projects where we just need to get some quick numbers to some concepts. If we build this with a 2-stud cavity, what is that going to do with the overall home? Or if we build this with a 2x6 and 4 inches of exterior, what are the impacts going to do? And it's a quick way that we can just build models, replace assemblies, and see what the overall impact is going to do to the heating and cooling loads. Key principle number 2 that I have is accurate heat load calculation, as we're on the topic, is our foundation. Otherwise, we are just guessing and using rules of thumbs and don't understand how each room is affected by heating, cooling, airflow, and being able to zone those rooms and size them effectively and properly. And in high performance homes, when you're building airtight and well insulated, there may be less of impact. You're not bleeding as much energy, so we don't need as much energy inputted into those rooms. but the overheating, overcooling can still very much happen in one single zone. This is a quick little example of our breakdown. We have the room load calculations, basis of a design, so that's what weather data, and a little zone legend. This was a bungalow, and just had to split it off with a main floor zone and a basement zone, and the impacts of the window AED chart, just showing are we overglazed in any areas or not. Key principle number 3, right sizing equipment, which I think we're all familiar and we hear a lot in the industry about properly sizing heating and cooling systems. But dehumidification and ventilation systems are often out of that conversation of right sizing. It is a real thing to over ventilate a home. And in my experience, what I've seen people do is, this is a big home, let's just get the biggest HRV that we can get. And that may not be what you think it is, especially again when we're building airtight and we see the impacts of what ventilation can do to your humidity and the health of your home. So ensuring that it's right size is important. Here we have number 4, adaptability and integration. So with this, I have a few points here. Tailor systems to fit the specific needs of the home, including the occupants, and integrate those systems into things like the architecture and design. Let's not just get a set of drawings, get to framing, and then realize we need to fit a 24-inch by 10-inch duct somewhere and result into bulkheads. If we consider some of the zoning opportunities that we have in projects, we can reduce ductwork sizing, we can reduce where those are going to go into the building and really integrate those things into architecture and design a lot more. Here for a little easy example, this was a project where we have mechanicals coming from the right side. And in this vaulted ceiling, we needed to get some ventilation to the bedrooms and office and bathrooms. We didn't want to drop the whole vaulted ceiling area with a 3.5-inch service cavity. So just speccing out how many of those 3-inch ventilation ducts do we need, and let's create a faux fake beam across that vaulted ceiling in the kitchen and line it up properly in a wall, and a problem solved for a cost-effective solution. Key principle number 5 is thinking about the utility room location, which is consistently becoming more of an issue. When the mechanicals are tucked in a corner and we have to distribute those by air or piping or what it may be, we're creating more work for the system to achieve restriction, to blow that air around. Imbalances, shorter areas may suffer or be overproducing, and your far areas could suffer. So keeping those mechanical rooms central is an easy way in the design that we can really help the mechanicals. Again, this isn't an every project, but it's something to consider, especially for homeowner builders when they have the opportunity to go through the design phase themselves. A few challenges and misconceptions. Number one, the missing link in mechanical design, like I touched on earlier, is dehumidification and ventilation. There is a lot of focus on, which is great to see the industry move towards more proper sizing and fitting of the heating and cooling systems, whether it's heat pumps, gas furnaces, boilers. But again, considering dehumidification and ventilation, they both suffer quite a bit. And when it comes to on the ventilation side too, who is doing it? What is the trade that's doing it? There's a lot of mechanical contractors that aren't really on board with the side of ducting things differently. You know, our code is saying we need a HRV or an ERV, and let's just duct it right into the furnace. But if we look at distributing those things differently with products like a flexible ERV, a 3-inch duct, all these go to a different manifold. When we've had different projects and I've spec'd this equipment, the mechanical contractor or the plumber isn't really up for doing it. So then who is wanting to do that work? But I think a step in the direction we're going, the more that these types of products are coming out, then the more people are going to be using it. And it's the same thing with air barriers, right? The role of that air barrier and exterior siding, is it the framer? Is it the sider? Well, now it's becoming like it's its own specific niche within the two. Misconception number 2, overemphasis on equipment brands and underemphasis on the integration of that. We've had projects that we've designed a single stage gas furnace and it performed really well because the parameters just worked out rather than multi-speed variables. And I am a big reason why I started the mechanical design part of what I do is not just being sold that I have to produce and sell one brand of equipment. There are many options on equipment, and we need to have an open mind on what those things are. We have misconception number 3, limited understanding or no understanding of makeup air systems. Builders and homeowners and architects are often missing the importance of a makeup air system. And as we're starting to build more airtight, there are things in the code that are stating when we need some makeup air systems, and there's some decent progress towards that. But when we build airtight, even so, the code is saying if your kitchen range is at a certain CFM, then you need a makeup air system. But we've had projects where we measure air tightness building of well under 1 and turn on a range hood that may be pushing it realistically 150 or 200 CFM, and it's already instantly putting the building into a good negative air pressure. So we need to consider what makeup air is and how to size it, but more importantly, once the equipment is installed, balancing it and making sure that your building, even once the equipment is installed, is still not being put into a negative air pressure or positive if your makeup air is pushing too much. And a simple way that I do that is crack open a window and tape it up and put one end of a manometer outside and leaves the unit inside so that we can just see a rudimentary way of measuring, is that building getting into a negative. So, misconception number 4, ventilation as just a reason the code is telling us, or just to bring in fresh air. But in reality, when we properly design a whole ventilation system, the distribution, the units properly sized, it is bringing in better indoor air quality. We're monitoring the indoor air quality. We are managing the indoor air quality and moisture, and it's an efficient way of bringing your heat and cooling throughout the home. If you're an airtight, well-insulated building, the heating and cooling system isn't going to be running all as much, or some, depending on how it's sized. But in those shoulder seasons, it's going to kick on for a bit, and the ventilation, with it being consistent, can carry that heating and cooling in throughout the home. So I see it as a balanced way to make sure the whole home is not just replaced with good fresh air, but it does help distribute our heating and cooling as well. And here we had a project just showing where our locations for fresh air and stale air were around corners from each other. And an off-the-shelf ERV that is quite common for people to get. This is a project outside of Edmonton, and in this thick wall cavity, we knew that there was going to be upper cabinets along this kitchen wall, which is going to create an even deeper nook with no circulation at that window. So we used Centrotherm to create a duct here and a notch out, or a little chase in the cabinetry. By the time that was cut off, the grill was flush, and it's a way to bring exhaust and airflow to make sure we're not getting any condensation or anything on those windows. Even with Innotek window, let's play it safe and have our kitchen exhaust location there. This other picture, you can just see that's a dual pipe to a single diffuser ERV ducting. So that's in the bathroom, and that's the exhaust duct there. Hi, Sean.
Don't let me interrupt you. Keep going, bud. Already looks amazing.
We got misconception number 5. Standard home building misses mechanical integration. The thought of mechanical. We get that set of drawings and just figure the mechanical systems are going to be added later. And that's the common phrase. That's always how it's always been done. And we get into design conflicts, not only on the mechanical design and architectural design, but there can be change orders that are easy to prevent. We can get less joists being drilled through with large holes by a little bit of mechanical design. Just bringing these people to the beginning of a conversation is really a way forward, I think, in building better. So practical tips for anyone who wants to build better. Start with heat load calculations, whether it's that RightSoft or hiring someone to do your heat load calculations and making sure that they're tying in things of the building envelope, the windows, the climate, orientation, and just avoid using those rules of thumb. In this, we all have thermal imaging pictures. This is just showing 4 wall assemblies, right? And that the loss of energy through infiltration, and when that infiltration is continuing over years, now it's making your fiberglass insulation deteriorate and less effective. So then over years, we're getting even worse performance out of buildings. It just really ties in, like how we started the conversation, the building envelope. Let's have a building envelope first approach. Building better number 2 tip, collaborate early with the design team. We'll hit that again. Having mechanical designers, architects, builders, the customer, if it's custom home project or for spec, we can do these things pretty cost effectively still, and just bringing people and consultants to the table. Tip number 3, prioritize ventilation and indoor air quality, and using the balanced HRV or ERV and the proper distribution. I am a big fan and a promoter of using the multi-bench systems, whether it's Brink, Excellent, Zender, to have those branch to manifold systems. Your whole home will be balanced a lot more effectively. You're going to get proper ventilation throughout your home by doing that. And again, with the indoor air quality is bringing that makeup air system to the table. Tip number 4, consider ERV and a dedicated dehumidification. ERV will maintain your humidity of your home far more effectively than an HRV. And the HRV is bringing that thermal transfer to capture the heat that we're exhausting out of the building, and so does an ERV. But the ERV is now maintaining our indoor humidity at safer levels and keeping whether it's dry air outside or moist air outside. And it's maintaining it both. If you're in a home where you produce a lot of humidity, whether by lots of cooking or showering or a house full of multiple people, then we may look at using an HRV. But most times I am a proponent of using an ERV and a simple dehumidification system. And tip number 5 is just thinking about layout. So like we said before, how mechanical room is effective, but regardless where the mechanical room is situated, think of how mechanicals are being traveled to the space to work through some of the bulkheading that we have to deal with, and consider what the impact of traveling ups and downs and side to sides and going under joists and then back up into a joist, what that's actually doing to your mechanical system. Here, with that being said, we had a project that they did a 20-inch, 18-inch service cavity across the whole bungalow. The ceiling, that was all for mechanicals, all for electricals. The air barrier was not touched. The electrician had ample space to run their equipment, and this is all the Centrotherm ERV ductwork. There's plenty of room to do that. And a finished look, you know, if this is built into your design and construction, if the homeowner is wanting that 9-foot, 10-foot ceiling, well, we can plan for it. Let's just have provisions for mechanical. And the installation of this was very simple. The end result is very effective without, again, the ups and downs and side to sides. And that's it. It's my presentation. Oh, also, have a few samples here, like I showed you guys, the Centrotherm duct and their diffusers. Yes, we just started being a distributor for this in Performance Haus. And again, this is an excellent system and a great bang for the buck. The diffusers, though, this is something that it's high quality, it's airtight, it's very sleek. It doesn't fall to your ceiling when you put it in.
I don't know if I could have those in my house, Kenny. Like if you don't have one fall out a year, I don't know. It's and that just twists to adjust the flow rate at the unit or at the diffuser.
Yeah, so this, if you need to do the micro adjustments, there's a tab that opens
Nice.
up. But how these systems are designed is that when we send a plan to Central Therm and talk to them about the layout of how we want to see the ducts run, they get the total length of everything. And on their document, there's these little restrictor rings, and they all tell us how many rings each run once they connect to the manifold. How many rings do we need to remove? And that will balance the system. Then once you need to do micro adjustments, then we can use this diffuser.
Very nice. Very nice.
Oh, cool.
I just want to push you back to when you were talking about makeup air, because it's something we throw out there. It's something we all know that we have to do. Um, I've had to do it for wood stoves in the past. I've had to do it for gas fireplaces in the past. But when you get into trying to do like more automated systems, and you and I have had a discussion about this in recent history. We have a project on the go where we're gearing it up for range hoods. So when somebody turns the range hood on, the makeup air automatically is provided. And I don't think there's a lot of resources out there for your average builder if they don't have like a good phone a friend option. If there's any resources for maybe explaining to a client better why they need the makeup air beyond, it's code, you need it. And just resources so builders themselves can understand the ins and outs of the equipment they need sometimes to do this well and do it efficiently and hopefully in a cost-effective manner too.
Yes, there are kits that you can buy. The Fantech is the one that comes to mind. That is the all-in-one makeup air unit with, it has filtration, it has the fan, it has the damper, it has a preheater that you can get onto it. And that's great. I really like that system and what Fantech does, and their range hood side of things, where you can have an exterior mounted motor, and it is extremely silent inside the kitchen. But there are cheaper, cost-effective ways of building a makeup air system with off-the-shelf products. The control side of that conversation is where things, I guess, are lost. How is the range hood going to talk to the makeup air, and what does it have to turn on? And is it 120 volt or 240 or 24 volt? And the relays and things that you have to get involved. So I agree there isn't really a resource of showing here's the options, but the code states you need it.
Well, there's a little a niche, a void in the ether, so to speak. Maybe someday we could have Kenny's resource on makeup air.
I have a follow-up, Kenny. So with makeup air, I have to admit this is something that we don't have a lot of experience with. We've installed a few systems, some small and some quite large and I think perhaps costly. But I think a lot of builders, they do really well when they understand allowances to put into budgets. So if you feel like you hear on the scope, okay, building a passive property or an airtight building, we have airtight goals. We do well with putting in like options. So let's hold an allowance for X in case we do need this kind of system. that gets harder later when the whole project budget's spent and now you're trying to add makeup air as an additional cost. Do you have a rough sense of what builders could use as an allowance for things like this? Is it a 2,000, 5,000, $10,000? Like what does that feel like for you when you hear makeup air system?
It's again, I'm very cautious on when I'm putting numbers out, depending
Sure.
on projects, and what side of the border you're on and provinces. But um, you can get equipment for that $1,800, $2,000 range,
Mhm.
and then the installation that can vary of how long the run is, how much insulation that you need,
Mhm.
where is it going to terminate into the building, the
Yep.
complexities of those. But off the cuff, I would say, if you're budgeting around that 5,000, you'd be safe. Could you do
Yep.
it less? I'm sure you could do it less.
Okay.
But
That's
again,
good to know.
bringing mechanical design into those conversations,
Yep.
then you have a plan for contractors to give them. If you want to get the pricing from your three favorite contractors, then they now have the information to go for instead of giving a set of plans and you're going to get three wildly different numbers and systems. And then now it's up to you to say which one feels right to me.
100%. I want to ask a question, then I'll open up to the floor or the colleagues. Is going back to your rule one, you talked about, the importance of understanding the base building and air leakage rates in those initial sort of benchmarking for heat loss. This is something that I admit we didn't have a lot of experience with before we started learning more about air tightness and the importance and the effect air leakage rates have on the building's heating demand. We would often reach out to our mechanical designer or trade, and they would give us whoever they were working with at that time to do heat loss calcs. We'd share with them the basic assemblies, and they take the nominal R value, so the insulation value in the wall and the window qualities. That's about all we supply. Later, we learned that a big factor in that heat loss is plugging in what that expected air leakage rate is. And when I started going backwards in old plan sets, code for us is 3 air change per hour as a minimum, but most calculations we had done have an air leakage rate much higher than three. So 3.5, 4, 4.2 air change per hour. Can you just tell us like where is it on the builder to advocate for maybe changing that air leakage rate? And do you know where that like 3.5 to 4 comes from that might be plugged in as a default?
There, depending on what software you're using, there are preset options on your air leak rate. So just tight, average, loose. And each one is a range of the air tightness.
Yep.
And as I started to get farther into the mechanical design, I found settings into that, like I mentioned, where now you can dial that into a specific ACH number. So I started to change what's this home that I just did a design with an average rate,
Yep.
and that could be the 3 to 5,
Yep.
or a tight. Then actually, I think tight was still at that 3 ACH level,
Mm.
the preset software. So I moved, okay, let's see what happens to a 1. And the greatest impact that we can do to our home on a heat load calculation,
Yeah.
it's the infiltration rate of getting that down to 1 or below, and windows. Those two are dramatic, the low-hanging fruit that we can do to our heat load calculations.
That's great. I think that's great. I think it's for me, it underlines the importance is if you're a builder, and we don't have a requirement here in Ontario to test our buildings for air leakage rate, but if you do, if you can see that you are routinely delivering 2 air change per hour, 1.5 or 1, I think that gives you a better case to advocate with your mechanical designer that listen, we are hitting these rates. We feel comfortable using this infiltration rate in the model. So again, Kenny or his colleagues can size appropriate systems. That's awesome.
Yeah,
Thank
you
you.
got it.
Just to echo a little bit on Connor, that's been a struggle for us in not just mechanicals but modeling. Just straight across the board, you have this historical data that says No, we typically build a house that is below zero point 0.6, and everybody kind of goes, yeah, well, this is what we're doing. Um,
Get an energy advisor to use below 1.
yeah, that's it is an issue, and hopefully the industry will move on. We are starting to get quite a few questions in the chat. If you're open for it, Kenny, you're up for it, we're gonna open the floor to some of our guests and get them to hop on and ask their questions if you're good with that.
Let's do it.
Okay. I apologize if I butcher your name, but Weon has a question. If you want to jump on and ask Kenny yourself, great. If not, I will ask Kenny for you. Just give him or her a second.
All right, can everybody hear me? Right. Kenny, the question was listening as a homeowner builder, listening to the pretty good house crowd in the States. There's the sort of antagonism to the wood stove idea, but in our climate on the prairies, living rurally, it seems pretty irresponsible not to include a wood stove. What are your thoughts around excluding that wood stove in a 3-season porch type of building, or a building that's within the conditioned envelope, the thermal envelope, but not within the air barrier, and using a set of exterior doors or something like that to just to exclude that from the air barrier, and then with a heat pump type of option. Have you seen that, and have you got any thoughts around that?
We are the same. We get quite a few projects where people are wanting the wood stove, and a lot of them have that direct fresh air intake to them, and a lot of them are built quite airtight too. So that's the biggest 2 cents that I could put into there. Otherwise, if you're outside of your conditioned envelope, I don't see any issue with it. And with its own dedicated makeup air system, or not even system, just a duct to the outside. Yeah, it's pretty safe.
Thank you.
Cody Scott has a question. If you want to hop on for a second, there we are.
When sizing the ERV, do you consider the air tightness of the envelope, like the ACH50 from a blower door test?
It's siding ERV is more so cubic meter of the home. That's the rate that I will look at to size how much air exchange do we need in the building. And then the infiltration, that's more impacting how is the energy that we just put into the home being lost.
Yeah, I agree with that. That makes a lot of sense. I just see some people consider the natural air leakage.
Let the walls breathe.
No, just if you already have so much, then you don't need to make up as much. But I'd rather pull it from mechanical than cracks in your walls or whatever.
Yeah, if your home is designed with a proper ventilation rate, whether you're airtight or not yet, and let's say you have the plans to getting your home built more airtight, if it's renovation case, let's say, you're now relying on the unit to produce it. The fans are not going to stop, so they're running. It will start producing the exchange that your building needs, and it'll just be less pressure on the infiltration happening into your building. Unless there's strong winds, that's going to go through your assembly. If there's something like a makeup air system that's creating your building to go into a negative air pressure, but sizing the ventilation unit to be based off of that cubic foot and relying on it is the safe way.
Yeah, I think that could be another misconception, that don't use the blower door test. when sizing equipment.
All right. I know Jeremiah's got a couple questions. Jeremiah, we might have to cut you off to save time for Peter and Peter, but hop
I'll
on,
go quick.
Jeremiah.
I'll be quick. I just have a question regarding ERV sizing, and wondering if it makes if it's logical or makes sense to sort of use the lower end CFM delivery on an ERV as sort of the guiding point. For example, if a house needs 60 CFM continuous, sort of at the normal range for sort of everyday living in the house, to have a ERV designed where the lower side of the CFM matches the house rate, leaving the rest of the room for boost on that ERV, but also letting the ERV operate at its slowest and probably most efficient speed when it's sitting dialed down, as opposed to having to sit halfway between whatever, if it's 60 to 130 CFM or something like that.
Yeah, I like the passive house suggestion and standard on that, which is sizing it for 77% of your ventilation load.
Right.
Even farther, I like things like the Brown and Venmar systems that have a wide CFM range.
Right.
And you dial it wherever you want.
Yeah.
So I like that, but always sizing it below so that you have room for the boost.
Yeah. And just one other quick comment regarding the Centrotherm system. We've used that and it's fantastic. So anybody who's having mechanical trades that are maybe reluctant to try something a little bit different, or even an independently ducted system, if they balk at something like that, it's quite user friendly. We installed ours ourselves. It was very straightforward. Everything is sent to you basically as a plug and play kit. So it's fantastic. I will say that I did find, because when you were mentioning the ring sizes that the system specs out when it's designed, I found that it was necessary to also take measurements of all the duct runs as they were installed, because the as-built versus the design don't always match. So if you have a run that ends up being an extra 10 or 12 feet longer or shorter, it may or may not make a difference on the adjustment of that ring size. So what I ended up doing was just taking all those measurements as I went and then sending it back to Centrotherm to revise so that they could update the ring sizes accordingly. But that was super simple and they were very quick to respond on that.
You're the poster child of installing Centrotherm systems.
It was great. I'll do it again for sure. Awesome. Thank you.
Awesome. Peter, if you're available, we would love to hear from you. There we go. I think you might be on mute, Peter. Nope.
Might be the fancy headphones, my friend.
Yeah.
Is that better?
There you go. Perfect.
Oh, helps you have the mic down. There. I was just wondering what penetration or mechanical device you want to introduce the makeup air from, so it can be controlled or conditioned before it gets into the house as well, or just a regular duct, but then you have an open duct out the wall.
Yep, it's a duct with a grill on the exterior, and that duct would be insulated up to a damper, a preheater, a filter, and the fan.
Yeah, so then it's controlled as it comes in and it matches the rest of the air by the measured amount. And as Aaron was saying, have it tied into when the fan is being used, then it kicks in the makeup air.
Yep, and it's really cost effective and easy for an electrician to add a fan control dial too. It's just a 120 volt or a 240 volt. That way you can do that manometer test to put a manometer on your building, have both of them run, and you dial the makeup air fan until you're at a neutral state. $20 saves you.
From time to time, test that as the most it stays the same, so it stays balanced later.
Pretty well. Yeah, the things like the clogged filter could change that, but
Just a quick follow-up on that, Kenny. We talk a lot about makeup air as the actual unit themselves having a damper. And have you looked at adding a mechanical damper to the actual range hood itself, past relying on the damper built into the actual like range fan?
I haven't, no.
Uh,
I will step in on this one. I did a lot of research on that, doing some high performance buildings, and I found a product that was a Passive House certified product. It's the only Passive House certified product for dampers, and it's this really unique kind of slinky system that turns and completely seals off, but extremely expensive and only really available in Germany. The product manufacturer is called Naber, and that specific product is called a Bixo. But Naber also made or makes another type of damper that opens and closes using earth magnets, and it only opens at something like air change pressure of 0.8 or something like that. So so it only opens up when there's actual some real forceful winds, and it's a triple damper that opens. And I've used it on several projects now, and I've used it in quite successfully. And even when I blew or door tested my house, I found that it did not actually open until like around that air change rate. I had to purchase that product from eBay Germany and then have it shipped over to Canada. So it was quite convoluted to try to get it here. I think now Amazon actually does offer it. So if you want to guys look that up, that one's called Naber Thermobox 150, and 150 is the size 150 millimeter. They also make a 125, but that's 5-inch, and no one's really using a 5-inch exhaust. That's a little bit too small, but the 150 is the largest they make, and they run about $100. So doesn't break the bank for that one. The Passive House certified one, the Bixo, that's several thousand.
Cool. Thanks, Grant.
That's great.
That is excellent information, because we've been actually looking at this exact thing for adding a little extra damper to an exhaust hood. So thank you for that, Grant.
Yeah,
I know. Go ahead. Sorry.
Oh, no problem. Let me find it in Amazon if I can. I'll put it in the chat.
That'd be great.
Appreciate that. We have a question from Peter Kim. If you are available, Peter, hop on and
Hello.
there we go.
Yeah, another Peter from Oshawa. Thank you so much, Kenny, for your presentation. I like the content and the design of the presentation. So my question is, what do you think about the using PHPP for load calculation? For small project, I'm not talking about the big project.
I really like the PHPP. It's nuanced. You can control it. It keeps everything accounted for. It's just very laborious. So for a small project, and even in a small suggestion, if someone's asking me some questions, I won't be using it. But for a quick and easy and get yourself to 80% of the way there, then I would look at using a right soft for a residential application. It's more user friendly, but if you're willing to go through the gamut of working in PHP, then yeah, it's up to the user's choice, basically.
HVAC came up with something called EasyPH that require much less input. Maybe that's another way we can go about it.
Yeah, I haven't played around with EasyPH yet, but I heard about it.
Thank you for your answer.
Sean, have you experienced anything with EasyPH?
My friend, most of the projects I've been working on, like the consultants or the architects are the passives consultant, and so they do it all. I do have to reach out to our good friend in Kelowna, and of course, Aaron. His name escapes me, but he's got a hack that he's been able to put Hot 2000 info into PHPP and be able to go back and forth. And I really need him to connect, Ben, to the world, because I think in Canada it could be a great opportunity for him to grow his business and also help out people. Because the big thing that PHP does well is just look at thermal bridging, and Hot 2000 doesn't. And so, you're just looking at that level of performance. PHP just takes it to another level, and you know how much energy you're going to need because the details are figured out. And I prefer that model just so much better. I mean, I understand it takes extra time and you can't find a lot of people, but it's just so good.
What I will do with PHPP on quick and dirty, get the numbers out, is I don't rely on the building assemblies on RightSoft, but I'll make the assembly on PHPP and pull out that U value, do the conversion, and plug that into RightSoft, just because I trust the numbers of what I'm going to get out of that route.
We're approaching the top of the hour. There's still some questions in the chat box. I just want to make sure you have time to go into overtime, Kenny. If you're good with that. Okay, here we go. All right, I know Leo has a question.
Hi there. Hi, Kenny. Thanks so much for your presentation. Can you hear me?
Yep.
I was wondering if you have any thoughts. My YouTube algorithm recently fed me some DIY videos. I guess they seem DIY videos from Europe of through the wall. I guess that would be an HRV. That it seems it's I'm guessing like 100 millimeters, 4-inch duct, like a fan with a ceramic heat exchanger, I guess. So it pulls air, I think, for 60 seconds or 90 seconds, and then reverses or something like that.
Yep.
I'm asking because I live in a Century home with currently a gas furnace that sort of takes care of the ground floor. And then upstairs, we've got like one duct that runs through the old walls, but basically the upstairs rooms are done with a mini split system with two heads in two rooms. So it's a bit of a hodgepodge right now, but I don't know what it'll be in the future. But I was wondering about sort of makeup air or, I don't know, air filtration with those things.
Yeah, I think Lunos is a great product for the right application. It is a low CFM rate. They are costly for what you're getting, but in a certain situation in small space or lack of space, it can be integrated quite well. There is the electrical that you need to get to the Lunos as well, so how you're mounting that. But one thing that I really like with it that we've experimented or seen in commercial buildings is that it can be tied into BMS systems so that the building management system can talk to them and control them more than just relying on simple controls. So they can get advanced the more you build into it. But again, it's a costly item for the amount of air movement that you're getting out of it. It's a costly route.
Okay, thanks. Again, I wasn't even looking for them. It was, watching too many other mechanical and building science videos, and the system starts feeding you these things.
I should mention that Leo's got some pretty cool air sealing details going on upstairs, and he's probably got the best shirt of the whole lot of us on today.
It's
But
it's my cooler weather work shirt, or one of them, I should say. Thanks
there
to
you
the long
go.
sleeves.
Thanks, Leo. I know
No,
we've got a
thank you for the
question.
t-shirt.
I know Jeff's got a question. Jeff, you still with us? There we go.
So thanks, Kenny, for your presentation. I've always been curious with ERVs or slash HRVs, what size of a house gets to the point where it's too small that makes sense to use one? Or does it just make sense to
Projects, 800 square feet, and use an HRV or ERV that can ramp down so you're not over ventilating. So off the cuff, the Brown BLP 150, it has rate, so you can set the CFM that you want it to do, and it will auto balance too. So it makes it more user friendly, so you're not exhausting too much or bringing too much fresh air. But for small space design, it's really effective.
Thanks.
Awesome. Al has a question. Al, are you still with us?
Yeah, still here. Yeah, hi, Kenny. Thanks for all the info. Yeah, one thing I'm looking at is just we've got a 1980s bungalow in Saskatoon here. We're doing some renovations on it, and the whole ventilation system needs a redo, basically. So looking at using different components. So other than the central therm systems and what Zendra offers for the flex ducting, do you know of anybody else? I've seen some other manufacturers making some UL certified fabric PVC type, smallish ducting, but it's more out of the commercial space than the residential.
Yeah, to have that UL stamp, it's that commercial fabric, which Zender offers. In Canada, we don't need that rating. So the Canadian code says that if it's ventilation only and non-tempered air, so not serving heating or cooling systems, we don't need it to be fire rated product.
Okay.
That applies to single family residential part 9, correct?
You got it.
Yeah, so part 9, it'll be okay. Yeah, and then it's just a matter of, how well or what those materials are like, for installation. Do they get snagged on stuff? Are they durable? That kind of thing, right? Because there's always people trying to get stuff around ductwork, right? So, okay, thanks.
I think we have got all of the questions answered. If I somehow missed your question, please chime in.
I have a question. I never put it in the chat. So makeup air, it's always extremely and costly. Well, it's not. It's costly and difficult to provide. I've built several high performance houses, and they've been all electric, so I haven't worried about backdrafting, and I haven't installed makeup air because it's expensive and it's another penetration, etc. I believe the code indicates if you're less than like 380 CFM, then you don't require makeup air. Is that right, Kenny?
I think it's 400.
Okay.
So just from what I know, depending on where you are in Canada, if you're following under the national building code, whether it's 2015 or 2020, it just simply states that if you have like a range hood, for example, you need makeup air. That's what it says. The IRC, I know down below us, it 400 CFM, and you need makeup air. But yeah, everybody's pulling up their it depends sticker. But I can't speak specifically for Ontario or BC and even Alberta. So just to interject that it does depend.
Right. So you're saying, from what you understand, under the new code, which whoever's under the just the NBC 2020, then if you have an exhaust hood, kitchen hood, you need makeup air. No question about it. Okay.
Externally ducted.
Yes, that is true. Gina just chimed in, just like the language sometimes is important. If you have an externally ducted range hood, makeup air. That's in the 2020, but it may differ slightly for Ontario or BC. I can't speak to that because it's really darn hard to keep up on everything.
Yeah. And just talk about a rule of thumb, again, codes are great because typically someone died and that's why it's in the code, is if you turn on your hood fan and you can't open the front door, you need makeup air. And that's, so if it means, and typically your hood fan is somewhere between 250 and 500, depending on, what you got going on there. But when we're getting airtight buildings, you'll be surprised. And I've done a few of my high performance homes, is the front door needs a snug. And you're like, okay, well, that means someone couldn't exit if there's a fire. Then you need to put a makeup air unit to do things. So, simple little rule of thumb of why you need makeup air unit is safety.
Yeah, for the sake of building science conversation and airtight buildings, I would say if you're putting in a range hood that exhausts to the outside, do the makeup air. It is detrimental. Better yet, don't have a penetration, and we can add a carbon filter.
Yeah, and I would say check out Kenny's Instagram because he's done a couple of really cool things when it comes to hood fans. And yeah, there's a whole nother story Kenny could talk about, is just hood fans. It's a whole nother hour.
Kenny, do you know, just to add on that, do you know any ERV manufacturers that can communicate to the hood fan and actually stop the exhaust portion of your ERV and just have your incoming air when the hood fan is on? You know what I mean? So instead of your ERV balanced, if that switch on your hood fan turns on, then your ERV, it send a signal to your ERV and it would shut down the intake part or the exhaust part of your ERV. And so you'd only be sucking air. I've talked to this about Zender, if they could do this, and they don't like that idea because in winter it would freeze the core.
Yeah.
But my response to that is, if that system is in place, you would just provide a larger preheater that could preheat that air to the point that it does not freeze the core. But that was all that came of it. It would be unique and efficient to use it in that way from my understanding, because you already have that hole, you already have that fan, you already have that filter. So why not use it?
I think it may basically come down to the manufacturing of those units and to how that would be controlled and the allowance to have an input to tell the HRV to shut off half of the unit. I'm not sure, but yeah, it could be more of a manufacturing side.
Yeah.
Yeah, just to chime in there. Sorry,
Go ahead,
I was going to say
maybe
the new Panasonics do, but that's the only one out of everyone that I've seen that is that smart. Most of them are a hard no because they don't want people messing with the technology.
And that's the other side is you're occupant of whatever beautiful structure you build. is going to play an important factor here. The hard thing for HRV, ERV manufacturers to dial in is they don't know what you're going to have or what your makeup air is going to be or requirements are going to be. So, quite possibly the inlet could handle maybe up to 400 or 500 CFM. But if, somebody decides to install a range hood in the house that is going to exhaust 800 CFM, maybe you just physically can't get enough air through that ERV. And that's a lot of the times where makeup air comes into play. There's just no other way. And it's just the most efficient way to do it.
I just have a simple quick question for you smart folks, smarter than me. When we're talking about the need to, I feel like I'm not a rule of thumbers, but I'd like to know some numbers. When you think about like CFM 50 in terms of like your leakage rate, so we're talking about ACH, but CFM 50, or sorry, CFM at 50, is there a relationship to say that because we can estimate if we're estimating or targeting 0.6 air leakage or 0.6 ACH 50, we can approximate the CFM 50. Is there a note to say that if the CFM of your hood fan is greater than your expected CFM 50, that you will be depressurizing? Is there a relationship between air leakage rate and this extractive hood fan to know that we will be depressurizing? Does that make sense?
I think I understand where you're making the connection.
Like I'll give you for instance. We have a project right now where we have installed a 300 CFM hood fan. It is directed directly outside. The duct run is 12 inches. It comes up and turns and goes outside. So let's assume on its highest mode, it's exhausting 300. This house at the first air leakage rate, the CFM 50 is 147. So the building understandably can only make up half of what the CFM rate could be. Could I extrapolate to say that we, definitely do? No, I know I need makeup air, but does that rule kind of show that the building can't make it up? Like, can we estimate that way?
I'm going to chime in and say the air that you're coming back in at, you want to be able to control that, just like our HRV conversation. So I wouldn't rely on the building's leakage
100%. Right.
to compensate for that, right?
Right.
Not that you couldn't model that out and probably
Right.
understand that, but I don't think I would want to as a rule of thumb.
So like for me, like that answer means back to what Aaron was saying, like if you then have a hood fan, then it's always makeup air because then we're controlling where it comes from. So maybe that's the safer route then.
The way I look at it is if you have an airtight building and you have a wood stove, you need makeup air because all the bad things that happen with a wood stove if you don't have makeup air, it's the same thing with a range hood.
Sure.
And not only that, but I mean, you fire up that 600 CFM range hood and your air leakage is in the neighborhood of 140 CFM, and then your windows are bowing in, and who wants that?
Okay, that makes sense. I think then it could make sense for those to add that allowance, right, in your base building before you have notes and assumptions to build in that scope. Because I can say in most builders' drawings, that's not on the scope. It's not from the architect, it's not from the clients. The builder has to advocate for adding that system. Nice.
And it gets tricky too, because what if you don't have a line item? Because quite often, we don't, like, at least in our market, we don't have externally ducted range hoods. Quite often it's a carbon filter and, it's just a recirculated range hood. And then when somebody changes their mind mid-build, it becomes a line item you have to add in.
That's fascinating. Like I think this year we've been in 100 houses and I've seen one makeup air system in Toronto.
Wow.
Wow. New construction?
New construction. Yeah.
Yeah.
This is from project cost between 700 and 5.6 million. Like massive, massive ranges. It's not there. So it's a huge part of the conversation that's just missing.
And I still think that, Kenny, you could do like an entire resource series on Makeup Air, and people would come seek you out because
Yeah.
the information is just not readily available. It's little nuggets that you have to go find yourself. There's no like, I went to Performance House and they solved all my problems, which I know Performance House could, but it's not readily known. So
Yeah, we're marriage counselors too.
cool. I
We
did not
all
know
are.
that.
Isn't
I
every
did not know that. Uh, I believe Leo has another question. So we're already well into overtime. So Leo, uh, please chime in.
Just because sort of fit right now. We currently only have a recirculating range hood. It is on an exterior wall. We just haven't, there's been just other priorities. But I was wondering, what are some retrofit options to the, like, any recommendations on how to reduce cooking smells and improve indoor air quality? Besides, I don't know, like we tried one of those countertop tiny little range hoods, but the carbon filter is tiny and I know it's not very effective. So I was just trying to think, like, what are ways when we cannot, when we don't have space or time or whatever for an ERE, what can be done short term?
Yeah, I would say, without adding the ventilation system and an exhaust 8 feet away from your range hood, I don't know if nothing's coming to mind of if there's like a temporary solution that could help you with the cooking smells, other than potentially, depending where you're getting your carbon filter, a better filter. In Edmonton here, we have a custom filter manufacturer, so we can just spec whatever grade of filter and size that we want and get it made right in house basically. That could be the only other thing maybe to seek out that's coming to my mind.
Okay. I wasn't sure if there were sort of some recommendations or experiences people have with, I guess, just standalone, how should I say, air filter systems for a room, just that, you'd put on the floor, put on the countertop or something like that. Just essentially, let's say you went to a client's house and are installing something with strong off-gassing of fumes during construction. You could also use it kind of like if you will, as an additional air scrubber, not for particles, not for fine dust particles, but an air scrubber just for smells. I could see an application there too. I don't know. I'm just thinking of like a portable system, maybe until we, can actually put in a different range hood. Which then also brings up the fun, of course, of having to also deal with Makeup Air then.
All right. Well, I think that brings us to the end, ladies and gentlemen. Thank you very much. And thank you, Kenny, for an amazing presentation.
Thanks so much for having me. We got a bunch of freebies. So I got a airtight sticker, Sega air shim, Performance Haus toque, and of course the quality Sega knife. Send anyone, first come, first serve, send us a DM at Performance Haus and we'll get your address and send you a kit.
That's awesome.
That is awesome. And thank you again, Kenny. Thank you, Performance Haus. And please just take a moment right now and plug BS&BEER Edmonton, Kenny.
Yep, we BS&BEER Edmonton, we started up last year, have some site tours happening, have some high performance projects happening in Edmonton. Like to get some more presenters and just building the community, get some we have homeowners who are interested, builders, architects, get people talking and a good Rolodex for everybody to kind of go through in our local market who's actually focusing on building science.
Well, again, thank you, Kenny, for joining us on BS&BEER Canada, and kudos to the amazing work you're doing in the building science community in Edmonton. You're getting some stellar turnouts, I will say that. And I don't know when it's going to happen, but I will make one in Edmonton, hopefully this year. And looking forward to having you back and talk again sometime.
That's great. Let's do it.
Sounds awesome. Thanks so much for your time. We appreciate it.
Great stuff, Kenny. Talk to you soon.
Bet, guys. Thanks so much.
All right.
Thank you.
Enjoy, folks. That's all for now.